Hi everyone. Today we're doing 1.2 solving one-step and two-step equations, which is due by class time on Wednesday. So to solve an equation, we need to know what an equation is. An equation is any math statement with an equal sign. In this equation, we need to know what we are solving for. We are solving for the variable x, so I'm going to circle that. Now, what's really helpful, and this is how we're going to teach it to you, is in order to get x by itself, we need to remove all of these other layers around it. So it looks like there's x, then there's -2, and then there's +4, okay, in this equation. This is an equation, so this is the left-hand side of the equation. Let's draw an equal bar down the equal sign. To remind ourselves, we need to apply the same operation on both sides of an equation to make it equal, to keep it equal. So in order for us to get x by itself, let's think about this like an onion. X is in the center of the onion. For me to get to x, it looks like there's a -2 and there's a +4 surrounding it. So to get to the center of the onion, I need to remove the outer layer first, then the next inner layer, then get to the center. To remove the outer layer, this +4, we need to apply inverse operations. Inverse operations are opposite operations that undo its opposite operation. +4's inverse operation, addition, the inverse operation of addition is subtraction, so we subtract 4. And I'm also subtracting 4 on this side of the equation, but particularly to the 10. Now, why is that true? 4 and 10 are like terms, okay? So essentially, we are combining like terms. However, when we combine like terms across the equal sign, we are using the opposite operation, okay? So we're doing 10 minus 4, which gives us 6 equals, now we have +4 minus 4, that cancels each other out. They're inverse operations, okay? And then we're just left with this -2x. Is x by itself yet? No. X is still attached to this -2. So the next part is to figure out, well, what's happening between -2 and x right now? What's the inverse operation that we need? Well, -2 is being multiplied to x. So the inverse operation we need is division by -2. Divide by -2. We're not dividing by -2x because the goal is to get x by itself on this side of the equation. So I don't need to remove the x with it. I only need to remove the -2. -2 divided by -2 is just 1. They cancel each other out, leaving us with just 1x, or just x is equal to 6 divided by -2 is -3. Okay? So what we just did here is we applied inverse operations to eliminate bubbles, or those onion rings, starting from the outer to the inner ring. And we know we are done solving when x is isolated, or by itself. Is x by itself here? Yes, it is. So in this case, our solution is x equals -3. Anytime and every time we solve an equation, we need to check our solution by plugging in that solution for every x, or everywhere that variable we solved for is in the equation. So this next part is to check. So to check our solution, we need to, let's first copy down the original equation. We have -2x plus 4 is equal to 10. Now I'm going to replace the x with a set of parentheses here. Let's keep -2 and then open up a set of parentheses. Plus 4 is equal to 10. In that parentheses, I'm going to write my solution. If x is -3, it should be true when I plug it into this equation. So I have -2 times -3 plus 4 is equal to 10. Well, -2 times -3 is 6. I'm going to write it over here. 6 plus 4 is equal to 10. 6 plus 4 is 10, and 10 is equal to 10. So I'm going to write it here. 10 is equal to 10, which is true, which means this is our solution here. Our check shows us that this is indeed our solution. All right, let's scroll down to the next section of this page, which is example number 2. So x minus 8 equals negative 17 is an example of a one-step equation. So what we have here is x means, well, when x is by itself, okay, that just means 1x. Okay, there's actually an imaginary 1 next to that x. So I'm going to go ahead and write that 1 next to the x. So what that tells us is in order to get x by itself, let's circle x because we want to get that by itself. We have a 1 next to it, and then we have a minus 8. And let's draw our equal bar. Okay, so we got to apply inverse operations now in order to get x by itself. We remove the outer layer first of the onion. So to remove that negative 8 in the outer layer, we need to add 8. Add 8 on both sides. Okay, now we have this cancels out. I'm going to bring down the 1x, leaves us with 1x is equal to negative 17 plus 8 is negative 9. Now this step, we're technically done, but in an effort to make sure we continue to use inverse operations, let's see what happens here. Well, x is still not by itself because of that 1 next to it. And what's happening between the 1 and the x? They're being multiplied. So the inverse operation of multiplication is division. So we got to divide by 1 on both sides of the equation, leaving me with x is equal to negative 9. Okay? Now the last step is to check. We have to make sure we check our solution. So we have 1x. Now I'm not going to copy the equation this time. Let's go ahead and substitute that with a set of parentheses. Minus 8 is equal to negative 17. I'm replacing that set of parentheses with my solution, negative 9. So now we have 1 times negative 9, which is negative 9, minus 8 is equal to negative 17. Negative 9 minus 8 is the same thing as saying negative 9 plus negative 8. That is indeed negative 17. I'm running out of space here, so I'm going to write negative 17 is equal to, is it equal to negative 17? Yes, it is. That's true. This is our solution. Now, if that check didn't work, that means our solution was incorrect. That's what goes in the space there. And then you would have to try to solve again. So go ahead and try problem number 3 on your own and input your answer into Edpuzzle.